never stop learning, because life never stops teaching.
Net to dev.
What we're going to learn on this video tutorial series is how to write smart contracts using Rust. And we're all used to write in Solidity. I know, why would I have to learn a completely different language if I already know Solidity? The reason why is if you're going to deploy an application that needs to scale, that needs to be fast, if we're talking about decentralized applications, we need to make sure that this application can process transactions near light speed. We're going to learn how to deploy Soroban smart contracts. This is the Stellar blockchain smart contract that allows to deploy decentralized applications in one of the fastest, most reliable blockchains out there. Stellar has been in the blockchain space for a long time. That means that the blockchain has been proven to be resilient. If we are building an application that needs to be resilient, cannot sustain interruptions in services, not mentioning any names, we need to write smart contracts in the platform, which means we need to learn how to write Rust. Don't worry, if you have not written any Rust application, I got you, because this video is going to get you in a more comfortable position to start writing Rust applications, especially in blockchain. We are going to be writing smart contracts that are memory safe. And what does that mean? It means that the code is going to be performance optimized, or code that will not be prone to bugs, okay? That being said, number one is understanding how does the smart contract layout is written in Rust, which changes not so differently from Solidity, which is a plus. If you are familiar with Solidity, you should not have major issues adapting that knowledge into Rust. And as we go, your mind is going to start connecting the dots. Let's define the string type. In Solidity, we type string, memory, name of the string or the variable that we want to use to store, then the actual string value. Let's do it in Rust. Let name value. That's it. That's a string. Okay. And don't worry, we're going to take a look at strings implemented in different cases. A byte type. We are going to be declaring byte 32, and then we will pen the value into byte 32. Let data equals, then byte bang, then we pass arguments. Very interesting. env, what is that? env is allowing us to import the environment onto the contract execution. The interface that allows me to communicate to the environment, aka the blockchain, okay? Then comma and the data. Awesome, let's continue. Now integers, let's work with integers. Now let's define a signed integer in Solidity. Int 32 name amount equals -10. That's an example. Now let's do the same thing in Rust. This is very, very similar. There's one thing that changes. Let amount colon, then we define the signed integer. We define the type. So we type colon, type equals -10. Very similar. The only difference, we define the type after naming the variable. Unsigned integer, uint 64 amount equals 10. Now let's do it in Rust. Same as what we did with the signed one. Let amount colon u64 equals 10. No brainer. Okay. Awesome. Symbols are strings, but more efficiently implemented in the Soroban smart contract. I can use a symbol instead of a string to define a string. So what I can do, I can define just like what we did with the integers. We can say let name of the string, but we are going to be defining this to be type symbol equals symbol underscore short bang, and then we add the string. Okay. What we are doing here, the symbols are basically strings defined in the Soroban contract more efficiently. We cannot exceed 32 characters, which means that I cannot go past 32 characters in the string. Also, I can only assign lowercase alphabet, uppercase alphabet, 0 to 9, and underscore. So those are my string that I can work with if I define this to be a symbol. If we add a sub-implementation of symbol in the Soroban SDK, that one it's called symbols underscore short. What that's going to do, it's going to even make it more efficient, because maybe we don't need that 32 character storage space. We just need less than 9. That is the limit in symbol short. It's 9 characters. The same requirements as a symbol, but the difference is we can use up to 9 characters. Great, because then I am defining strings that will not take too much storage, and the smart contract is going to be more efficient. Okay, awesome. Now the moment. Let's build that smart contract and let's see the difference between Solidity and Rust. As you can see in Solidity, it's very straightforward. Contract name, and then we initialize and start writing the contract. In Rust, however, there's two things that we need to do. First of all, we need to initialize the smart contract as a public structure. Why? Because it's storage. A smart contract, what is going to do? It's going to store data in the blockchain. It's going to be defined as just instructions to store data, which means that it's a structure, right? It's a structure that includes functions that allows me to store, calculate, compute, manipulate data. So what we're going to do, we are going to be importing the contract crate from the Soroban SDK. Don't worry, I'm gonna go through that. What we do, we add the pound, we encapsulate in brackets the contract word. That is the crate that we need to import into the contract, okay? Then we define this to be pub struct, then the contract name. Okay, once you do that, you have initialized that contract, but we need to still implement. So what we're going to do, we're now going to do the implementation. From the Soroban SDK, we're going to be using contract imp. That will be the crate that will be used to initialize this smart contract, to implement the smart contract, I should say. We are going to follow the same approach as we did with the contract, then define to be contract implement. That will be the crate. Then we define this below. We type imp contract, and then we start working with our smart contract, okay? How do we start defining functions inside a Soroban smart contract with Rust? In a Solidity function, we start writing that function with function, then the name of the function. We pass the arguments, if any arguments will be passed onto the function. Then we define the visibility, the state visibility of this function. It could be internal, it could be public, it could return, okay? However, in Rust, we are going to be defining the function visibility first. That means that if it's going to be public, meaning that it's going to allow interaction outside of the contract environment, outside of the contract state, I have to define pub, then fn as in function, then the function name. When we define the function name, as an example here, we have the function name to be defined as register vote. What we are going to do after that, we have to pass the environment. Once again, let's talk about the environment. If, let's say, for example, you know in Solidity, if I need to request a block number, if I need to use the block number, the current block number, when that function gets called, I have to call block, then dot, then number. For example, right? In Soroban, in Stellar, what we are going to do, we are going to be using environment. That is, quote, my link to the environment, to the blockchain, so then I can interact with, for example, transaction hashes, IDs, numbers that are being defined in the blockchain because it's something that is constantly being updated. Let's say the block number in Stellar is the ledger number. Okay, so every ledger is, quote, the block number. I want to obtain the ledger number when that function gets called. I will be invoking env, which we imported as an argument on that function. Then we will type that ledger. And we will do an example so then you are more familiar with it, okay? Okay, so let's do a sample Solidity smart contract. First thing, we are going to be importing an interface that will allow me to do console log. And the reason why am I doing this is because I want to show you what will look like in Rust, okay? We import, and if you work with Solidity, you know that with Open Sapling, you have a lot of libraries, a lot of interfaces that you can import and use. Let's say, for example, Safe Math, Safe ERC20, Safe ERC721, and you know what I'm talking about, right? So let's go ahead and import console log from the hard hat environment, the testing environment. Once we import that, we are going to define the smart contract after defining the compiler version. Okay, so in this case, the Solidity version that we're going to use to compile the smart contract. Then we define the smart contract, type the name of the smart contract, and then we start with our journey to write. Okay, so what we're going to do, we are going to be building a smart contract that is going to allow us to vote. Okay, so it's going to be registering vote. What we need to do first, we are going to be defining a struct that will store all the user information. Let's say how many votes a user submitted, the choice selected in the poll. And also we are going to take the opportunity to grab the timestamp when that user did submit those votes. We are going to create a struct called record. Then we'll add all the properties of that struct. So then we can start organizing that data as the user starts hitting the contract and registering vote. We have to map, we have to do a mapping so then we record and index data per user, per voter. So if a user 1 goes and votes with the mapping, I am going to be passing a number. I am going to be passing a type, an attribute that will be allocated or will be mapped to the struct. So every time that I call that, it's just going to store those values assigned to that particular user attribute or ID that we want to map to, okay? So let's say user1, then we call mapping, and then we store data for user1. And those are all my variables that will be updated based on that information that we obtain. User2 votes, then again, we're just gonna have a mapping for user2 with the same data. User3, user4, user5. Awesome, very straightforward. Now we define another struct. This time it's a struct that is going to record how many votes were allocated to yes, for example, how many votes were allocated to no, and how many votes in total. All we have to do is we have to record those actions in the function, and we have to send the data to the right destination depending on how many votes and what was the choice selected on the call, okay? And finally, we have to map because we have to access that struct so that we can pass the data and store it. With the mapping, I can create multiple polls because if I index this mapping with integer, I can pass poll 0, that will be the first poll. Then I can also open a new poll. I can say poll 1, and then I can store yes, no, and total for poll 1. Then I can open another poll, poll 2, poll 3, and poll 4. I'm pretty sure that you understand what we're trying to accomplish here, okay? Now, the moment to write that function that will record the vote. Function record votes. Then we will pass the arguments. We are going to obtain the username. For example, we're just gonna pass a string value of the username that is voting. Then we will capture how many votes is that user submitting and what the choice is going to be as a string. The user will only be able to pass either yes or no, okay? We're going to define this to be public because absolutely we want the user to be able to hit that function from a front end, for example, okay? We start the function. The first thing that we are going to do, we are going to declare an unsigned integer uint256 time, name time, and then what we're going to do, we are going to record the block timestamp because we just want to record the time when that event was triggered or when that vote happened. Now we are going to take the opportunity of the console log that we imported at the beginning of this smart contract. We're going to type console.log, and then what we're going to do, we're just going to pass some string values that when we call this function, we should obtain the result of that vote and we should see what happened, okay? So we're going to type console.log. First one is going to be user, then I'm going to be passing the user the value of user, then we are going to be passing another console log, time, and votes, okay? This is very straightforward. So let's go ahead and run this function. Let's deploy the smart contract and test it out. And very straightforward, we go to Remix, then we deploy the smart contract, and once we get the smart contract deployed, we should have available record vote. Remember, this is a public function, meaning that I should have access outside of the environment of the blockchain. So I should be able to interact. It's not an internal function. What we're going to do, we're going to vote. The user is going to be net2dev, okay? Votes 12, and selected, the choice is going to be yes. Hit transact. If everything goes well, we should see the console log because remember, the function is only grabbing the timestamp and then showing a console log. We're not actually storing any data. We're just showing output. That's it, okay? Awesome. How do we implement this in Soroban, writing a Rust smart contract? Well, the first thing that you need to know, in Soroban, there is an online IDE similar to Remix. You're probably very familiar with Remix. So there's an online IDE called Okashi.dev. In Okashi.dev, I have a live online IDE that I can use to write my smart contracts and compile and emulate just like a virtual machine that we have in Remix. So when we open here, we're gonna go right below on the lower left corner and hit new project, okay? This will open the compiler with a sample smart contract that we can follow to get familiar. We're gonna write our own, okay? So we're gonna delete everything. Now, what we need to do, the first thing that we need to do to write a Soroban smart contract is to prevent importing the Rust standard crate. This is the standard Rust language crate. Why is that? This is a smart contract and we need to make sure that it's only following the standard Soroban SDK implementation. What we are definitely going to import is going to be the Soroban SDK. In Solidity, we type import and then we specify what the contract or the file for that import will be. In Soroban, we are going to type use, then we'll define Soroban SDK and we'll place a double colon. What that's going to do is going to basically open that crate. And by opening that package, I am going to look for crates that I need to import into the smart contract. Which ones do we want to import? And obviously we need to have in order for us to build a smart contract. The contract, as you remember not long ago, we have contract imp, that's the implementation of the smart contract. Then we want to implement the environment because that is critical for us to be able to interact with the blockchain and store data in the blockchain, build our functions and make our calls, etc. So we are going to be importing env, and then after that, anything else that I need to use on the smart contract. Symbols, if I want to define symbols, I need to make sure that those crates are imported. If I want to log messages, similar to what we did with Solidity, I will be importing log. Okay, so let's go ahead and do the same smart contract as we did on Solidity and Rust. Okay, so we define contract as you saw previously, define contract. Then we invoke the contract crate. We define this to be public struct vote contract. That will be the name of the smart contract. Then we proceed to import the contract imp, and this will allow us to do the contract implementation. Okay, we define imp vote contract, and let's start writing. Let's build that function. Remember on the previous one, it was a function, then the function name, then the arguments, then public, because that's the visibility. Now it's different. Pub fn function name. In this case, pub fn record votes. What's the first argument I'm going to be passing? Environment, because I got to make sure that I have that available, because I need to be calling the blockchain and obtaining that ledger number. Okay, then I am going to be defining a string argument called user. So we type user colon, then we define the type. This will be a string, comma, then the next argument. What's going to be? Votes. We need to know how many votes is the user submitting. Define votes colon u64 is going to be an unsigned integer. Next, selected. Selected is going to be the choice, either yes or no. Selected colon string. It's going to be a string. Awesome. Let's start. We are going to be opening this function and let's start writing. The first thing that we are going to do, we are going to obtain the timestamp, similar to what we did with block timestamp. How do we do it in Stellar? Let time equals env. This is where we start using env. Dot ledger. There we go. We are working with the ledger. Now we are going to type dot timestamp, and this is how we obtain the ledger timestamp or the block timestamp in the EVM flavor. Okay, awesome. And now let's go ahead and write the console log as we did in Solidity, but now we are going to use the Soroban SDK log that we just declared. Remember, we called log, so that's how we import in the Rust smart contract. We now can pass a log, bang, then we are going to pass the first argument. It's going to be env. It's always going to be env if I need to log, because again, we are going to be interacting with the blockchain. So we have to make sure that the implementation includes env. Make sure always. As a matter of fact, it's going to error out if you don't. Okay. After we pass env, now we're going to pass comma. Then, for example, we want to display the username. Then we type as a string user colon, then after that comma, then we pass the user variable, the argument that was passed by the user. That includes the value. Then we should see the username. Same goes. Once again, do the same thing. Let's display the votes. And finally, let's display the timestamp. Once we're done with that, we want to check and compile. So let's go down, click compile. And if everything goes well, we should have the record votes function ready for us to test. Okay. Now let's go ahead and hit record vote. We are going to be passing the first argument. It's going to be the username. We're going to pass the same net2dev vote count. Let's pass. Then the selection is going to be yes. We'll hit call. Then if everything goes well, we should see in the output the same console log as we saw in Solidity. How cool is that? But we're not done. This is literally just the icing on the cake. Now we're going to learn how to index and store data in the blockchain. Let's see how can we do this in Solidity. We'll do it very quick, and then we'll go deep into the Rust contract implementation. So the first thing I'm going to do in Solidity, we're going to go back to the smart contract. I am going to be placing 3 requirements. The first one is going to be require votes. Votes must be higher than 0. Okay, else we're not allowed to vote. Okay, so the user must be passing a value that is higher than 0. Number 2, we are going to make sure that there is no timestamp store for that user, meaning that that user hasn't updated the struct that includes all the information about vote activity. So what we're going to do, we're going to be calling that registry mapping, passing the user as the map ID or the parameter that we want to map for. Then we will return the struct with the data. Then we pass dot property. In this case, it's going to be time. Then we'll say it has to be 0 or else you're not allowed to vote. Then we'll do another one that we want to make sure that the user doesn't place more than 5 votes, for example, in one transaction. So we're going to say require. Now what we're going to do, again, we're going to check if votes is lower than 5, then perfect. Else you're not allowed to vote. Okay. Now let's write. The first thing that we need to do, we are going to be storing the information from the user. We're going to be calling the public mapping for register. Then we will pass the username as the key to that mapping so that we can find the storage for that user. Now what we need to do, we are going to be registering the information that the user has provided, aka the voting. Registered, that's the mapping, the public mapping name. Then we will pass the user as the key in the mapping so that we can locate the struct with the data of that user. Then we'll place dot, and then we will be able to interact or modify the particular property inside the struct. So I'm going to type dot name, then we will pass the username, dot selected, what was the vote decision, what was the choice, either yes or no. Then we'll pass the value that the user selected. Then we'll pass the vote, that includes the amount that the user is passing. And finally, we will pass time. This will be the block timestamp that we define at the beginning of this function. Now I gotta make sure that if the user is not passing the string that we want them to pass, because remember, the only thing that they can pass is either yes or no. With a string, I cannot compare two string values because that's not allowed. So what we need to do instead, we are going to be hashing this using keycat256. We are going to be encoding the string, and then we should obtain exactly the same values from yes. So then we know that this is yes, okay? Else it's going to be no. So what we need to do, we're gonna type the two parameters, what the user is providing versus the string yes. And then if it matches, then we'll go ahead and proceed to register that vote. We are going to now call the polls mapping. Remember, that's a public mapping called polls. Then we'll pass 0. This will be the first voting section in the smart contract. Then what we need to do, we are going to type dot yes. And what we need to do, we need to pass the value of how many votes were allocated to yes. Okay. But we also have to obtain what was already stored in that struct, because if we don't, that means that we are overriding what the value was before. So we want to make sure that we just increment what was existing, which means that I have to obtain what was there before. That's why I'm invoking it once again, then typing plus, then votes. Then I'm just going to grab what the value was there before, then I'm just adding vote, okay? If the condition is not met, then I'm going to go and allocate those votes to no. And finally, we want to just record how many votes have been executed so far in the smart contract. What we need to do, again, vote, we got to just call poll 0. Then now we are going to be invoking total. Then what we need to do is obtain what was already there as total, and we're just going to add the amount of votes that were registered on that call. Let's deploy the smart contract. Let's record the vote, pass the user, net2dev, votes for choice yes. Transact, and everything goes well. Let's take a look at the polls. We have successfully stored 4 votes allocated to yes, and we have a total of 4 votes. Awesome. Let's bring another voter, John, and let's vote. User, John. Now John is going to vote no, and it's going to allocate 3 votes. We're gonna go and transact. Done. Now we take a look at the polls. We have 4 votes yes, 3 votes no, and a total of 7 votes so far. If I call the registry, I can pass my username, and I should obtain the information regarding my votes. I can see when was the timestamp and how many votes were allocated and the selected choice. Now let's build this in Soroban. Okay, so how do we store data in the smart contract? What we're going to do, we are going to be implementing structs, and we have to enumerate every entry that we allocate on the struct. Very similar to what we did with mapping. The only difference is that instead of me doing the mapping and then defining the type of map, in this case, I am going to be pointing integer to the struct. That means that every time that I pass a different integer, there is a completely different struct allocated. So if I have user 1, then I have all the data for user 1. If I have user 2, I am going to have all the data for user 2, and so on. This here is slightly different. So what I'm going to do first, I have to define contract type. So contract type allows me to bring enumeration capabilities onto the smart contract, allows me to build structs that are going to allocate data on it. So this is for me to allow to invoke and create those structs, because those are also types. Structs are types, but instead of us defining strings or defining integers or defining symbols, I am going to be defining an enumerators. Very high level explanation. There's a lot more involved, but I think this will at least give you the idea. I am going to be defining contract type. So I have to, first of all, invoke that, right? Similar to what we did here. So I want to do a copy that, and then I'm going to add type. Now I am going to be providing, I'm going to say options that we can allow this particular type to be invoked with. Okay, so one of the options that we can allow this contract type to do is clone. Why is that? Because when we execute functions, right, if I want to reuse user, it's not like in Solidity where we invoke any value from the struct and we can just reuse it. If I want to reuse that value, I must clone or copy. Okay, that's one of the two options that we have in Rust, is that we can clone the value so that we can use it below. Let's say I am obtaining a value from the poll, and let me just define it and we'll go through that, okay? It's kind of confusing, but then once you start building the functions and you realize that if you use the value, you need to clone it before you can use it again. So the value that was used right there, we have to clone so that we can keep using the same value below, but it's gonna make more sense once I write the function. I'm gonna say derive, and now I'm gonna say clone. Now, I want to build a struct that is going to store the amount of votes in the poll. Amount of yes, amount of no, and the total amount of votes, okay? So what I'm gonna do, now that I define this contract type, now I can define that struct, okay? So I'm gonna say pub, I'm gonna say poll. Now, inside this struct, we can define very similar to what we did in Solidity. As a matter of fact, this is very, very similar. I want to say pub, it's going to be yes. And the reason why it's pub, because we're going to be interacting with this information outside. It has to be set as public so that we can get that information outside of the contract environment. And yes, it's use64. Okay, so this will be use64. I'm going to say pub no, also use64. And then finally pub total is going to be use64. As a matter of fact, this is comma, this is comma, this is comma. Okay, perfect. All right, so we have the first struct, right? Now, in order for me to access this struct, I am going to be defining a constant that will be attached to this struct. Don't worry, it's going to make sense. So what I'm going to do, I'm going to say constant, and we are going to define poll, put this in cap. Then we're going to define this to be a symbol. By the way, we're going to be using the symbol. Now what I'm going to do, as a matter of fact, if I'm using symbol, that means that I have to import this from the Soroban SDK. So I'm going to say symbol right here, okay? Now we're going to say equals, and now we're going to define symbol short, bang. And now what do I want this character string value to be? It's going to be poll and caps, okay? So now if I have this, okay, I can use this to reference what was defined in this particular section of the smart contract, in this case under poll. The moment I do this, if I do this, now whatever it's inside here, then it's not referencing anything that it's here. So I'm going to be working, whatever am I going to be defining down here, this will not be referenced here. What I'm going to do now, what we're going to do a function that will view the poll information, okay? And then we will use this as reference, so then you understand what I'm doing, why this is done this way. Let's do the following. I'm going to go down. I'm going to say pub, right? What we're defining is going to be pub function, and we are going to call this view, okay? What is the first thing that we have to import? We are looking for the poll. There's not going to be a mapping that on this smart contract, this is literally just a single poll. The only argument that we need to make sure that we have is the environment, right? Because we are going to be working with the environment. So let me do here so then you can see it better. Perfect. Now, how do we return in Rust? How do we return the value so that we can see what is the value, and also we can use the values in another function? What I'm going to do, I am going to be passing what is going to be the return that I want to get from this function. Poll. That will be the struct. We want to obtain the values inside this poll. Now, this is the way that we specify that we're going to be returning, and then whatever it's the output. This will be defined here. It could be U64, it could be unsigned integers, it could be a string, it could be, you get the idea. This is literally the object that I'm going to be returning. I want to say, now what I have to do is the following. Any data that we need to interact with will be in the storage section of the environment. How do we access that data? Well, the first thing that we imported was environment, right? So I have to type environment. Now we can invoke storage. And now we want to find inside that storage, the entire storage of the smart contract, the instance that we are looking for. And that's it, instance. Okay. Now we are getting the instance of the storage. Now, what instance do we want to get from the storage? It's going to be the polls. And the word get is what we use to get that data. Okay. Now we are going to pass inside as an argument for get me what? The poll. Okay. What I'm doing right here is I am going to do what? I am going to call this constant that is attached to this here struct. With this, I can effectively call whatever is north here, like whatever is defined here as poll. So let's go here. I'm going to type all uppercase. Okay. And I got the information, right? Rust is very specific. You need to tell Rust exactly what you're going to do with that. Okay. Well, I'm getting it. Well, you haven't told me once I get it, what am I going to do with this information? We are going to unwrap. Okay, unwrap it. I want to see what is inside. Okay, but If you don't find any information, let's say you didn't get any information regarding that, meaning that there's nothing stored on the smart contract for that poll, I am going to do lowercase or this is like a conditional operator. This is very similar to a conditional operator. We can say unwrap it, give me whatever it's inside there, or return a poll. And this, what that's going to do is just going to return this value because we are defining a brand new poll right here. We are defining exactly this down here like it's an empty poll. Okay, this is what we're going to do. And now, what do you think I'm going to do? I'm going to write the struct, but it's going to be empty. So we're going to say yes, 0, because we are not defining a type struct. Listen to me carefully. We're not defining a type struct. We are defining a struct. There's a big difference. We're not defining the type. We are defining the struct. Repeat after me. When you define outside of the contract implementation, you are defining types. Okay? When you are defining inside the smart contract function, or you're defining what the object is going to be. This is very crucial for you to understand the difference between how do we define in Solidity or any other programming language versus memory safe like Rust or C. If you are familiar with C, God forbid, I got stories of C back in college. Anyway, okay, so what I'm going to do here, I am going to be defining the actual values. We're not defining a type, we are defining values, which is very different, okay? We'll say 0, no, okay, so we're defining no to be 0, and finally total is going to be 0 as well. Okay, so what I ended up doing right here, ladies and gentlemen, is the following. I define function via poll, then I'm just passing the environment. This will give me the information about my contract on the blockchain. Again, we are interacting with the blockchain under the environment. Then we are going to return a poll because this is defined to be the type poll. Now I want to open that storage inside that smart contract, and I want to get the instance poll, which is defined here as a constant, which is then passed to the struct, which will then open and see what the hell is inside that struct, okay? If I don't have the poll, if the smart contract, and this is one of the key functions and the key aspects, I'm going to say the key features of Rust, is that if I don't have any object, if you unwrap, there's nothing here. I don't want you to error out or cause like a bug because we are going to be able to use this function on another function to obtain, and then we can reuse those values, right? We can do a function to do a callback to get another function, and then with those values we can do something, right? So what I want to make sure as a safety mechanism, is to return, if there's nothing found, return this poll that is showing all zeros, okay? Now that we did that, you can see right here, right? What I'm going to do now, I am going to compile this, and hopefully we don't have any errors. So let me go ahead and compile. It's compiling. And we can see there's a problem. Okay, so this is easy. So basically what this is doing is that we are missing this macro. So we are missing this implementation or this macro from the Soroban SDK. All we have to do, I'm just going to copy this because I'm lazy. I'm going to paste it. I'm going to recompile and see what happens. Now we haven't found the take the value of storage. And let's see. Oh, you know what? I made a mistake right here. Past this, right? I forgot that. Okay. We're gonna compile. There we go. Awesome. Let's see here. It should be a snake case name. Try record votes. Probably should be this. I'm gonna show you here. So if I do that, that should take care of the issue. There we go. No errors. So let me take a look out at this. I'm gonna basically recommend to use snake case, which is basically everything lowercase, underscore, lowercase, and such. Okay. Again, you're adapting to a different programming language. It is expected. Okay. And now poll, it's all good. I was missing this. Go ahead and do view poll. Let's see what we get. There we go. Awesome. So what we are returning, because there's nothing stored here, there's nothing defined inside the poll, then I'm just going to return this by default. Okay. Now I can use this function inside here if I want to, which we will use. Okay. Now that I gave you the scoop on this, now let's build the other struct. The struct is going to record the votes from the users. Okay. I am going to define another type. This type is going to enumerate, okay? Because we want to be able to store information about voters individually. So every voter will have its own section in the storage, okay? So we're gonna say contract type. We're gonna be using contract type once again, right? This one is not going to be cloned because I don't need to clone, but don't worry, you'll see why we need to use clone or not, okay? So I want to say contract type, I want to say pub struct record. And now inside record, we are going to do exactly what we did in Solidity. Okay. So in record, I am going to type pub name, and the type is going to be a symbol. We're going to be using symbol. Now we're going to say pub selected symbol, also going to be a symbol instead of strings. I'm going to say pub votes. This will be integer. Let's do unsigned 64. And let's say pub timestamp. We want to record that timestamp. Also U64, okay? Now that we build that struct, now we have to define enumerate. This is going to make more sense. The difference between mapping and Solidity in Rust, we can use enumerate. That is one way to do, quote, a mapping. So what I'm going to do, I'm going to also, by the way, have to do contract type as well. And then this one is going to be pub enumerate. We're going to be enumerating, and we're going to call this registry, similar to what we did in Solidity. It was going to be registry, but now inside here, we are now going to point to the struct, okay? I am going to pass the struct name, record, which is this one right here. And inside this struct, I will be passing type symbol, okay? I am expecting to pass on registry to enumerate. I am going to be passing the string value of the username. The moment I pass that here on registry, because we're going to have it here because it's public on the registry, when I pass the username, the string username, obviously it's a symbol, but again, it's going to be a string value. When we pass it, then on the record, we can find the records for that particular user, okay? So this is how we do it. This is the type of mapping in Rust. It's very different from Solidity, for sure. After that, I think we're done. We have that. And by the way, the contract type, again, we are going to be cloning. So I have to make sure that I can clone it as well. So we have that there, right? And now I will be doing the same compare that we did in Solidity, where we have to do if the answer or selected is yes, then store yes, else just store no. We are going to be doing the same thing in Rust. The only difference is that I have to define them to be like symbol types outside of the scope of the implementation. Then I'm just going to pass it. And again, I know that there's many other ways to do it. This is the way that I'm going to do it, just because I want you to get familiar with this implementation, which is very important, okay? So what I'm going to do is pass it here. Look at this very careful, okay? So I'm going to say define constant. I'm just going to do it this way. I'm going to paste, and I'm going to say here is going to be yes. And I'm going to be passing the string value of yes, the string value of no, and I'm going to say no right here, okay? So now we have both yes and no, and now we have the registry. Let's do the following. I am going to build a function to get the information from that registry as well, to view that info, the same thing that we did with poll, but it's going to be slightly different because now instead of me just getting the poll struct, I have to pass the value that I'm going to obtain for that particular record, aka the username, okay? So I have to pass the voter name so then I can obtain and I can get to that record, okay? I'm gonna copy this. As a matter of fact, so you can see it better, I am going to just enter here. I'm going to enter. Now, let me close a little bit of consoles here. Now, this one is going to be called view voter. And what am I going to be returning? It's going to be record, okay? Because that's the struct that we want to get the information from. Now, apart from the environment, I also have to pass the voter name, okay? What the name is going to be, because that's going to be an argument that I have to pass so that I can obtain the information for that user. So I'm going to say voter, and then it's going to be symbol, because it's going to be a symbol value. Now what I have to do, I have to make sure that I can pass this onto the instance so that we can get the information for that voter. Now I have to make sure that I can clone the value of the voter, because that is how I can reuse the voter value anywhere else. Remember, I am going to be invoking this function when we register votes or record votes. So I have to read here, and then I have to be able to pass the voter somewhere else. Like I have to pass that voter value somewhere else. Let's do it, and then you should be able to get it, okay? So I'm gonna say key, I'm gonna say let key equals. Now we are going to be invoking that registry. Here's the moment where we are going to be invoking that struct. So we are invoking that struct, but by calling the enumeration registry, okay? So let's do that. I'm gonna say registry. Now we are going to navigate inside that registry, and now we should be able to call record. And what am I going to be looking for? It's going to be the voter, but now we are going to use that clone option, right? The reason why is because this function, I want to make sure that the voter can be used somewhere else. It doesn't make any sense now because this is the function to view, but it's going to make sense once I build that record votes and start data onto that record vote, okay? So now, instead of me passing poll, we're not going to pass poll, obviously, we're going to pass. So we are going to be passing key, okay? We pass key, and then basically what we're going to do is recreate the same scenario. We're going to pass a brand new struct in case we are not able to find information for that user that just by default shows me absolutely nothing. So what are the values inside this record struct? Let's just take opportunity to just copy this. I'm going to paste it here. And then what I'm going to do, instead of the type, we're just going to delete that and add some message. Okay, I can say that means that if you unwrapped and didn't found any information about the voter that was passed, the value of the voter, then under name, I am going to just pass another string with not found or something like that. I'm going to say symbol short. Again, we're going to use that macro symbol short. And then inside symbol short, I'm going to say not found underscore. That means that there's no information for net to def. Let's say we pass my name, no record found or like no data stored, then just pass this, okay? This will be the or. Under selected, again, we have to pass a symbol. Why we have to pass a symbol? The reason why is because that's what's defined as the type here. That's why we have to pass symbol, but then here it's going to be integers, okay? Let's just call this none. We were not able to find that. And then under votes, it's going to be 0 and pass 0 because again, there's no record for that user. Go ahead. Now this is looking good. What I'm going to do, I'm going to compile, see if we found errors. No errors. Awesome. Now we are going to try view voter, and then I'm going to type my name. Net2Dev, call it, and you can see what we're passing, not found, known, 0, because again, nothing was found. I am going to do this. Let's delete all this, right? We are going to store data for every voter, and we have to determine if the voter vote yes, voter vote no, and all that. Okay, now we're going to say user is going to be a symbol, because now it's not going to be a string, it's going to be a symbol, because that's what we are going to be passing here. Now on the record votes, it's going to be a symbol. Now votes remains as integer, and now we have to pass selected, okay? And the value is going to be symbol. Now we're going to say let. Now we are going to be working with mutate. So when we define this variable to be mutate, that means that we are going to change the value when we execute. That means that this can be updated. Else, we're not going to be able to update. Okay. This allows me to mutate the state of that variable. Now we're going to say records. Now we say equals. What we're going to do, we are going to be calling view voter because we can call this function and store the values inside here. Then we can manipulate the values and we can do whatever we want. So I'm going to say records. Now I have to say that I am going to be interacting with my own smart contract with this instance. This is where we can also call other smart contracts and get information from other smart contracts. But in my case, I'm going to tell Rust, hey, deal with self, with myself. Okay, boom. Now what we do, we're going to type view voter, right? And the first thing that I'm going to be passing is what? Environment, ladies and gentlemen. Again, environment. We have to pass the environment. And what am I doing here? I am cloning. Why? Because I will be reusing environment down the line. As a matter of fact, I'm using it here. That means that if I use it here and I didn't clone the values, it's memory safe, remember, that means that I cannot use it here. Now, I can continue using the same values here. That's why I'm allowing it to be cloned so that we can continue using env down on the execution, okay? Now, after that, we're going to say user clone. Again, we are also going to be cloning user because that also will be used across the entire function execution. We want to contain time, so we still want to store the time because we're going to be updating the time value here when the user votes. We are going to make sure that the user doesn't pass a value of 0. The user hasn't voted, which means that the time value for that user must be 0. Else, if it's not 0, I'm not going to let you vote again. And finally, that the vote amount is less than 5. We're going to allow it up to 5. Again, I know this is, this is not a true vote smart contract. This is for me to show you how to implement this type of storage and how to manipulate that kind of data, okay? So I'm going to say if, and here we don't need anything enclosed. What we do, votes, we're going to say equals 0. If votes are 0, that means that the user is passing 0 as votes, or records. Now we are going to be calling the records. So we're going to be calling records. Then we're going to say dot time. That means that inside records, we are grabbing the value of time, okay? So time must be equals to 0. If it's not equal to 0, that user voted already, okay? We don't want that. Now, after that, we're going to say, or, sorry, I didn't do the condition here. So records time, if records time is not equal, so I'm going to say not equal to 0, or we are going to say votes are higher than 5. So if any of those conditions are met, that means that the voter either voted already, is having an incorrect vote amount, that vote value is 0. So it's not, any of those conditions are not allowed. What am I going to do? I'm going to panic. So then we stop this from continuing execution. We're going to type panic. This is kind of similar to require. This is similar to assert in Solidity. So basically what it does is just panic. I'm just going to panic. I'm not going to continue executing this function. Okay. I'm going to say panic. I'm going to say bang, and then we're going to pass some string value, say cannot vote, okay? With this, I will just stop the function from completing. But then else, if it does work, if it's not matching this right here, then just continue. Now we can define the function. Let's say let mutable poll. Now we are going to obtain the values inside the polls, and inside those values, we are going to work with those values. We are going to determine how many votes so that we can just keep adding more votes to it as users continue voting. And again, it's going to be very similar to this. I'm just going to take opportunity to copy that, paste it on here. Okay. In this case, it's going to be poll. We are going to invoke this function, which we already have available in the smart contract. And poll doesn't have like an enumerate, right? So this is the poll. As a matter of fact, you can see it right here. The only argument is the environment, which is what we should have, and that's it. We should not have anything. Okay. So we have view poll, environment clone, and that's it. Okay. Now we have that poll variable available for us, so then we can manipulate. Now let's store the values for that user. So we're going to say records, we're going to say name, and now the name, what's going to be the name? User, right? Because that's the information that's being passed by the user when we hit record votes. But again, I have to use clone. I'm going to use user down on the function as well. So I have to keep cloning that value. Now we're going to say records selected. What we pass as the value is going to be selected. Okay. There we go. Records dot votes, and we are going to pass the votes from the user when the function got executed. And now we're going to pass that timestamp. Records time equals time. Remember, we defined this. We got it right above here. Now we have to determine if the user voted yes or voted no. So what I'm going to do, I'm going to do another if, and now we have to define if records selected, okay, equals yes, but this is not a string. This is a variable that was defined here as a constant that matches the string value, which is very different. This is not a string, by the way. I already defined whatever was yes and no, so then we can use it down in the execution. So I'm going to say yes, okay? Then I want you to update the poll. So I want to say poll dot yes, okay? This will be the value inside the poll. It's going to be equals to what? It cannot be equals to votes because I am effectively deleting what was the amount that was already stored. What I have to do, I have to define it again. Poll yes plus votes. That's how we just add to the existing amount stored in the poll, okay? Else, again, you know what's going to happen. Poll no. Okay, so the user has voted no. Cool. And now finally, we're almost done here. We are going to say poll total. Okay, so now we are going to be updating the total amount of votes by saying poll total. It's going to be the same amount. Again, we just want to update plus votes. Okay, this will be the amount that the user passed. So now we are updating the total amount by adding the votes that were added by the user. Now we are going to be saving the data. You know, in Solidity, we don't need to like do anything after invoking the property inside that struct. We just update it. Once it completes executing, that I don't need to like, okay, store it or save it. In Rust, I do. So I have to work with the environment storage, and I can either do the instance, then set. Set, it's to set or to store, to update the state of that particular struct, aka to save the data. Or I can do persistent. In Stellar, you have to make sure that the data on the blockchain gets the timestamp. There is a time to live. It's a time to live that you must have to poke at it, right? So then the timer resets and the data doesn't get purged on the blockchain. Okay, so this is a way to make the blockchain more consistent and not have a lot of garbage that is never being called and it's just stored there forever. So what I'm going to be doing is I'm going to type persistent, and then I'm going to set the data. Okay, and the first thing I'm going to do, I am going to set the poll. Okay, so I'm going to be storing the value of poll, but I cannot just send this here onto set. I am going to be storing the data by invoking the poll, right? So let me fit right here. You see it right here. Let's set the registry. We're going to be interacting with the registry. Now we're going to say record. Now what we are passing, this is where we store that data inside that struct by calling the enumeration, so then we can find a particular record for that user. And what we're passing is the user, right? So the user value, that's why you can see here that I cloned that. I cloned that because I need to reuse that here. And yeah, after this, I don't need to reclone it again. That was the last time I'm going to be interacting with this value. And then I am going to pass what? Inside this particular enumerate, then find me that struct, and then we are effectively passing the values onto that struct. We're going to say records. So with this, I am effectively updating everything that was updated in the memory. Then we are passing it onto storage and making it persistent. That's it. That's how we store it in the smart contract. Now we're going to copy this because we are going to also store the information about the poll. Now, instead of me calling registry, we are going to be calling poll. Okay, so you can see it right here. And we are effectively saying, because that's the value that we were updating. That's why we set it mutable. You can see it right here, mute poll, because we are updating the value of this particular variable, and then we're passing it so then we can restore this once again. Now we are just going to show a log, right? So we're going to say log this, and then finally we are going to say, obviously we got to pass the environment. Environment is always first. Then we are going to say votes registered. Woohoo! Awesome. That's it. Return to finalize the function. This is it. This is a function that will allow users to vote and allows me to store multiple votes, allows me to update the poll. We did a mapping, quote a mapping. This is enumeration, so that we can pass these values onto the struct based on the user account. With it, pretty much every basic interaction in the Rust smart contract in Soroban, okay? So now I need to do this. I am going to compile and see if there's errors. See if there's errors. Oh, so the first one is we are no longer using string, so let's remove it here. Okay, so we remove the string, method persistent. Once again, check this out. No worries. I made a mistake of not invoking this, right? If we don't invoke this, guess what's gonna happen? Nothing is gonna work. Okay, so we're gonna compile and see if we're looking at. Beautiful. We are very lucky. Okay, so we see compiler string is unused. String, it's not used. Okay, so let me delete it here. Let's see. And we have constant no, never use. Actually, that's true, because I'm not using no, I'm using yes only. So as a matter of fact, let's be proactive. Let's remove this. And now we are going to say yes, and it requires an uppercase. We're just gonna follow this. So I'm gonna say yes, uppercase, and that's it. Let's see, way better. And there's a uppercase name, so all caps, just like the poll, just like what we did with poll. You see, Rust is like very picky. There we go. No more console. Okay, perfect. Console has been cleaned. Actually, no, I need the console. What I don't need is the compiler. Okay, there we go. Awesome. So now let me work with that. So let's give it a shot. So let's see view poll. We can see that 0, nothing is being shown. View voter. Let me pass my voter value, a voter name. I'm going to say Net2Dev, not found. Let me pass another value. Let's say John. Boom, not found. Awesome. Now record. Okay, so let me record my votes. Net2Dev. I'm going to say vote. Let's pass 4. And we are going to be voting yes. Boom. And we can see that it's registered. So that means that everything went well. Votes registered. Let me try to vote again. We should have a panic because I already voted, which means that my timestamp is updated and I should not have 0. I should have higher than that. Well, 0 is what I pass as an argument. Okay. So when I say view voter, let me find my account. Let me make sure that my votes were registered, and my votes were registered. Awesome. And I can see yes, I can see the timestamp and my votes. Let me try to vote again using my name, and we should see a panic. Sure enough, we can see the panic. We were not allowed. Now let me vote as John. I want to say John. I'm going to vote 3. I want to say no. The answer is going to be no. Boom, votes registered. If I try to vote again, it's going to panic. And now let's see the poll. Beautiful. No, 3, 4 yes, for a total of 7 votes. There you have it. We have completed this amazing introduction onto Soroban. On the next video, how do we deploy this on the Stellar blockchain? And how can we interact with a web application? How can we do JavaScript calls to Soroban? Well, that's coming up next. As always, thank you for your support. Give it a thumbs up if you find this tutorial very useful, and we'll see you on the next video. Bye.